Okay, so here we have one question on the um, electric potential and the force. We have two parallel plates here. We don't know which one's positive and which one's negative, so it doesn't give us that information. They are separated by 10 centimeters, and a potential difference of 500 volts is between them, is maintained between them. What is the force on an electron placed at 2 centimeters from the bottom? So a force on an electron that's down here. Again, we don't know which plate is positive and which one is negative, so that would determine the direction of the force. So if this one were negative, there would be, and we have an electron here, they both would be negatively charged, so they would be repelling each other, so the force would be going in this direction, downward, because it would require a force to keep this electron here. If it were positive, then the force would be going up this way just because they attract, so you'd have to have a force pulling in the opposite direction. So the equation for the electric field is E minus V divided by D. We are assuming a uniform electric field, doesn't say anything differently. The force on the point charge is given by the electric field times the electric charge, in which case we're going to take it as 1 coulomb. So here again we require two equations to solve for the initial question, which is what is the force on the electron. This is the equation for force, but we're not given the electric field, so this is the electric field, so we will have to take this information here and put it into here so we can solve for the force. So again, this is a case where you required two equations to solve this problem. So that's where your cheat sheet will come in handy. Go, I'm looking for the force, I don't have the electric field, oh, but the electric field is, the potential divided by the distance. Perfect. So plug those in, and what we get is 500 newtons. The next one is how much work is required to move an electron from position 2 centimeters from the bottom to 2 centimeters from the top plate. So that would be a total of 6 centimeters that we're moving it, right? This is a total of 10. There's 2 here, 2 here, so that's 4 centimeters total. So 10 minus 4 is 6 centimeters distance that we're going to require it. Work is force times the distance. We know what the force is now. We know the distance is 6 centimeters. We're going to change this to meters, which is 6 centimeters is equal to 0.06 meters. So we end up with 300 Newton meters. Okay, so that is that problem.